Hello everyone, welcome back to Engineering Graphics YouTube channel. Friends, in today's session, we are going to solve a problem based on isometric projection. And the problem statement is, the figure shows front view and top view of an object. Draw isometric view and give overall dimensions. Now, front view, from front view and top view, we can find the length, width and height of an object. Now, this is the orthographic view. 2D view is given, and in isometric we convert two-dimensional object into three-dimensional object. For isometric view, isometric projection, we require a isometric box, and for isometric box we require a x, y and z axis. Now in this problem, the origin O is given at the left bottom corner. Now from this O we can find the front view plane. So if observer is looking from x direction, so observer will get front view in this plane. It is the first plane. This is the second plane. If observer is looking from y direction, the observer can see a side view, and this is the third plane. So this is a x-axis, y-axis, and the vertical axis is a z-axis. Now we require to draw a isometric box for this problem, and from front view and top view we can find out the overall dimension. Now you can see here, from the center line to this edge distance is 40 mm, because outer circle radius is given 40 mm, and from center line to that center of circle the 65 mm distance is given, and from the center to this outer arc radius is 25. So 25 plus 65 plus 40, so the length of this object is 130 mm. Width of the object is 64 mm, and height from this base to top height is 40 mm. So from front view and top view we can find out the overall dimensions, and from overall dimension we can draw a isometric box. So on x-axis we can mark a length, on y-axis we can mark width, and along z-axis we can mark a height. Now see the solution of this problem. Now draw a horizontal line. On this horizontal line mark a point O, take a protractor and mark 30, 30 and 90-degree angle. So this is a x-axis, z-axis and y-axis. Now mark length along the x-axis. So length of the object is 130 mm, width is 64 mm, and height is 40 mm. Height of the object is 40 mm. So erase the extra lines. From this dimension, from this length width direction, we can draw a first plane, second plane and third plane. So this is a z-axis. This is a 64 mm distance. Already we have marked a height. So along y-axis and along x-axis draw a line parallel to x. Now adjust a ruler along width direction and draw a line parallel to y-axis. Adjust a ruler along x-axis and draw a line parallel to the y-axis. So by using this method we can complete a isometric box. So this is a x-axis, and along x-axis length is there, this is y-axis, width is there, and vertical is the z-axis. On z-axis we can mark a height. Now let's see the problem. In this problem this object consists of two different parts. This is part first and this is part second. The part first consists of a two concentric circle, and this circle, half circle, has 64 mm width. So we required a rhombus. You can see the outer circle diameter is 80 mm, so radius 40 mm, so 40 into 2 is 80 mm. So we can draw a rhombus in the first plane from this point, from O dash. You can see this is O dash point. This is O and this is O dash point. From O dash we can mark this point, and this distance is 80 mm. So we required a rhombus here. This is ATM distance, and along this on this plane we can draw a vertical line. On this vertical line, mark a 40 mm distance. Find the midpoint. 40 mm is the midpoint of this straight line. This is also 40 mm. Now these two are the obtuse angle, and we know that for circle we required a center points. So by using obtuse angle and opposite side mid, we get a circle centers. Join the obtuse angle and a opposite side midpoint. Now in this problem, the upper half circle is given. So for this circle, take C1 and this C2 center. Now you can see here, take C1 as the center and take this radius in a compass and draw a 1/4 arc. Now take C2 center, take this radius in a compass and draw a next arc, 1/4 arc. Now for this 50 mm diameter circle, find the center point, and we know that the center point for this is on 40 mm. On this 40 mm, mark a 25 mm distance. We require a rhombus here, 25 mm and 25 mm. Adjust the ruler and draw a vertical line. On this vertical line, mark a 25 mm and a draw a rhombus here, 25, and this is 25. Now join obtuse angle opposite side mid. Join obtuse angle and opposite side midpoint. Now for this 50 mm diameter circle, take C3 and C4 center. Take this radius and compass and draw a 1/4 arc. Take C4 the center and draw a next 1/4 arc. Join the baseline. These two lines we can see in the front view plane. Now this part have 64 mm width, and by using tangent we can show the 64 mm width. Backside, at 64 mm backside, we can see a circular part, and for the circular part, shift C1 and C2 center along the width direction. So shift C2 and C1 along the width side, 64 mm width. This is the new C1 dash, and this is the new C2 dash. For this arc, take this radius in a compass, shift C1, shift center C1 to C1 dash. For C2, take this radius and compass. Now from this edge also we can mark a width by the thin line. Join this edge. Now we have completed this part first. Now we will draw the part second of this problem. Now this part second is again, it have the circular section, and you can see here the two circular parts we can see here. The part the first circular part is at 15 mm. and the second circular part is at the base level. So we can draw a rhombus at 15 mm height from this base. So from this base, mark a 15 mm distance. This is 15 mm distance, and find the center. 64 divided by 2. The center of this part second is at 32 mm. Now you can see here the diameter, outer circle diameter is 25 mm. So we require a rhombus of dimension 50 by 50, and this circle is on a horizontal plane. So mark 25 mm and 25 mm distance. Adjust a roller along x-axis and complete a rhombus here. Mark it 50 mm distance. This is 50 mm. Center point is on 25 mm. 25. This is a 50. Complete a rhombus. So we have find the center points. These all are the midpoints of all these sides. Now join obtuse angle and opposite side mid. Join obtuse angle and opposite side midpoint. This is a obtuse angle and opposite side mid point. Now we required a outer circle, and for this circle, take a C1, C2, C4, C5, and C6 center. Take C5 center and join these 2 points. Take C6 center and join these 2 points. Now this edge is join this edge directly. This here is the point. Okay. Now for this there is a arc we can see here. Before that, we can complete a bottom circle. For this circle, we are required to shift C5 and C6 15 mm downside. So shift C6 and C5 15 mm downside. Mark a 15 mm distance. 15 mm. Now take a compass. Measure this distance in a compass. Draw a tangent. Draw a tangent. This reducing compass. This is new center point. Here also arc cricket. You can draw this arc. Now again there is a circular hole at the center of this part second, and position of this circle center is 65 mm from this center line. So mark a circle center, it is 65 mm. It is a circle center here. Now the diameter of circle is 20 mm. So make a rhombus of dimension 20 by 20. 20 mm. 10, 10. Adjust the roller. Now these two are the obtuse angle, joint obtuse angle and opposite side mid points. Now biasing rounder, join the end points. This is a 1/4 arc. This is also 1/4 arc. The circle is very small. So we have completed our problem. This is a time consuming problem. This edge you can see here. So this is the solution of this problem. Now give the overall dimensions. So this is a lane. So total length of this object is 130 mm. Height is 40 mm. And width is 64 mm. Now see the solution of this problem. This is a front view direction. One line is missing here. The depth of the circle, the circle is throughout. So draw a line along the width side. This is the front view direction, and this is the top view direction. Try to solve this problem. Thanks for watching this video. Keep drawing and keep learning. Thank you.